Good evening, and welcome to the Cloud Native ORAN Testing in Your Pipeline. I'm Watson, and we've got Andre here from SRSRAN, so you're in for a treat today. So who are we? I'm with the Vulk Cooperative. I work on the CNF Test Suite, which is part of the CNCF, and I'm going to get into that a little bit later. And then we got Andre, who's the VP of SRSRAN and CTO, basically. And it's going to be really his introduction to this community here for the One Summit. So I'm very excited. So our agenda today is going to be about the SRSRAN project. We're going to talk about ORAN interfaces and why we want to test them, and then we're going to get into the specific interface that we test. And we're going to talk about the tools that we use to test, and then we're going to give a quick demo, and we're going to make this a little bit more interactive for people that maybe aren't in the mobile space or what have you, and we're going to be asking questions and these types of things. And okay, take it away.
Let's take that back for a second. Can you guys hear me okay? Perfect. So what is SRSRAN project? So short answer, it's a 5GSA CUDU implementation, layer 1, 2, 3, written from scratch. So probably a little bit over 2 years ago, we sat down and thought about what would be the perfect software basis for implementing a CUDU. For 5G and potentially 6G, of course. And so we looked at existing projects and implementations, and including ORAN E2, including our own 4G code, right? So before we doing that, we were actually using our 4G code base and doing 5G SA and NSA prototyping actually based on our 4G architecture. But we kind of decided that that's not the optimal way, because of all the new interfaces that 3GPP brought in and that ORAN brought in. So we decided to throw that all away and rewrite everything from scratch, but in a good way. And that's how we started SRSRAN project, which is, as I said, a complete implementation, including layer 1, 2, 3. So we always say from IQ to IP. And our goal is really to focus on the CU and the DU. So all of what you're seeing here in the picture in green-blue shade is what we are doing. So we have, from the start on, designed all the interfaces into it rather than taking existing architecture and adding all those interfaces into it, which always ends up with a complicated and unoptimal solution. So from the start on, all the ORAN interfaces are implemented in the architecture. We have proper CU-DU split. We have the split between the DU, high and low. To the outside, we expose all the interfaces that you expect the CU and the DU to expose. So to the core over NG or XAN, to the rig and to the SMO over E2, over A1. And one of the most important things from our perspective, and in quite an enabler for for ORAN, the open frontal 7.2 split implementation that we also have, and that we can actually run with the same architecture. At the same time, we're also supporting frontal split 8, which is basically a user P or split 8 RUs with the same architecture. And then complete, I already mentioned that, so it's a full L1, L2, L3. So there's no third-party dependency, so it's the entire file written with SIMD vector instructions, so it's very performant as well. So we have a very portable system running on ARM, so you can actually run the file on ARM. You have open frontal on ARM. We don't rely on third-party dependencies that restrict you to certain CPU instruction sets. So it's very portable. It's performance, so we're reaching world-class, best-in-breed performance on any given architecture. The entire stack is open, so it's all accessible. By flexibility, we mean that even though the software architecture provides you all the layers that you might be using, and we recommend using them, but you're not restricted to do so. So you can, for instance, take the FAPI split and use FlexRAN or NVIDIA Aerial or any other third-party PHY, and then just take the L2, L3 for your DU, and then obviously use a CU or combine it with another CU. And it's very interoperable. So obviously we have all the interfaces there, and then so you can combine them as you see fit. And again, the fronthaul is a very important thing. So you can actually run this architecture or run this software on ARM, on x86, AMD, and also on Intel in a very performed way. I don't want to dwell too much on the features here, but the bottom line is that you have all the key features that are of interest for private 5G. It's all Release 17 aligned. We have all relevant interfaces implemented, all bandwidths for FR1, up to 4T4 MIMO, 4 layers in the downlink. I already mentioned ORAN split 7 for our use. All RRC and MAC procedures are there, including mobility, so you can actually have multiple cells and do handovers between them. Performance is targeted for real deployments, and that's something that is really, I think, unique. So you don't have that in similar projects. So from the start on, we thought about, and then we made sure that we have this the capability to run and deploy that software. So looking at 500 plus 1,000 UEs per cell, 24/7 operation, a 1500 megahertz. This is for 4T4 100 megahertz cell configuration. Looking at a 1500 megabits downlink, 200 megabits uplink without hardware acceleration per cell, and that's something that you can run on a normal server. So at MWC, actually, we did a live demonstration there using on an AMD EPYC Siena server, where we actually had 800 megahertz 4x4 cells running on a single EPYC server, using or serving 500 users per cell, all unaccelerated on the same machine, so not using hardware acceleration. One of the goals for SRSRAN, and that has been the case for 4G, and it's even more so the case for 5G, was to simplify telco, to simplify ORAN. So whoever has set up or tried to set up an ORAN system, it's not easy. It's not exactly easy, and it actually unnecessarily complicated. So we spent lots of effort in improving documentation, providing documentation, not only for the code, but also for testing, to write guidelines, to write application notes, so it can get people started quicker. We have set up the docs.srsran.com as a single point of contact for all those guides. Code is hosted in GitHub. We're using GitHub discussions and then obviously issues for engaging with users, and we encourage everyone to participate there. And then now to get a little bit the move towards the testing and the testing needs that obviously we see, we recognize. And then this is something that obviously comes also from the ORAN concept and disaggregation of the RAN. So you have many more components now, and you have many more interfaces and potentially vendors that you need to interoperable test with. So this increases the testing needs and requirements tremendously. So even more so if you're looking at deployments, I mean, you really want to make sure that all your components work and with the vendors you pick. And certainly for everyone who's involved in RAN testing, end-to-end testing is always complicated when it involves RAN equipment, and so that's not as easy as. I'm not saying it's easy to test something that runs in the core or in a data center, but RAN is certainly more complicated because it involves all those kind of stuff with real equipment. And so you really have to tackle this with various means. Obviously, we are doing very extensive in-house CI/CD testing, testing our software. So we are just a little bit under 5,000 unit integration tests there. So we really focus on testing units of our software, and then doing integration tests, obviously, among them. But I mean, at the end of the day, you also have to do end-to-end testing. They are more costly, and that's why you focus on unit integration tests. But at the end of the day, you have to do that. And we are doing that with, with all sorts of radio equipment, COTS phones, CPEs, M2 modems, ORAN RUs, various ORAN RUs that we are running there. And then we also utilizing ORAN test and integration centers and people who run those, like for instance, the Powder testbed at the University of Utah, who have an outdoor deployed ORAN capable, outdoor testbed essentially that we use and to test our software. But the vision really is to go even further, go beyond that, right? So we really think that we really require, as a community, like for ORAN and all for all this to happen, for all that to basically be deployable and usable, a truly open, inclusive, and vendor-agnostic testing facility there, where we really can test end-to-end, have open test plans, and going beyond writing test specifications, but also having the test cases as code, so they can be tested across vendors, across revisions and releases of software and DU and CU, and that's something that I think is really required. And with that, I think I'm heading over and handing over to Boston again.
Show of hands, who's in the mobile space? Okay. And then those who are not, you just drank from the fire hydrant, right? So that was painful. But I will say, and I see the open air interface, I'm not a radio engineer. I was able to get a Faraday cage, get a radio, get a commercial off-the-shelf phone, use the documentation that they used, and make it connect to a phone. So it actually works, obviously, and it's the significance of that is when you're trying to make it to where you have a community where you have regular tinkerers or what have you, writing tests and trying to innovate. Technologies like this and technologies like the open air interface, things like that, we need to work on what he was saying here with this vision, truly open, inclusive, vendor-agnostic testing facility and open test plans and test cases as code. The only way you're going to be able to get that is if regular people can install the stuff and actually see it work. So that's the significance, I would say, for those who maybe trying to follow along. And so here, I'm going to get into a little bit about the test suite. So we were with the CNCF. The test suite used to be called the CNF Test Suite. In the CNCF, now it's part of Linux Foundation Networking. It's called the CNTI Test Suite or Test Catalog. Essentially, what it does is it tests cloud native maturity or cloud nativeness of a workload, really any workload, but we specialize in trying to test telecommunication software. And here's some of the community. The project's been around for about 3-4 years now. And so we, as far as trying to come to terms about what's from the cloud native community, and then we come to the network telco community, what's a cloud native RAN? What I would submit to you is that it's a RAN with the software components deployed to a cloud native architecture, uses immutable infrastructure, declarative configuration of microservices. That would be more of a definition coming from the cloud native community. And we'd say You can do that in many ways, but one way to do it would be to take the RAN, and put it in containers, and host it in Kubernetes. Some of this is what we test. So why would we want to test ORAN interfaces? So the test suite is historically a horizontal non-functional test for cloud nativeness. And what we wanted to do is bring some of that over to the telco community, networking community. One of our biggest requests from, say, operators and others was to start testing more telco-specific protocols. And we also noticed that some of the operators were very committed to ORAN. So we went ahead and said, okay, well, let's go ahead and build something out to try to test the ORAN interface. And we thought that was logical. What we really want to do is facilitate vendor onboarding and vendor interoperability with community-maintained tests, going back to what Andre was saying before. So some of the challenges that we ran into is that RAN is expensive to test. You'll continuously run into people who say, oh, well, that's going to be almost either impossible or what have you. You're going to have all these equipment, or what have you. One way to push back on that is to have some type of emulator. There's lots of emulators that are closed source out there and very expensive, or what have you. SRSRAN has an emulator. There's other emulators out there. And so taking an emulator and trying to make a harness without a test harness so that you can start testing some of these things. Other things we ran into is like, how do you identify, these pods are specific within the cluster. So, okay, what is this, an AMF, or is this the DU or CU or whatever it is? So we're going to talk about identifying those things, and then how to capture the network traffic. Capturing network traffic is easy in a regular environment, on Linux, but then doing it in Kubernetes, sometimes you run into issues. So these are things that we ran into. So let's talk a little bit about what we decided to test. And Andre can jump in here if you want. So we tested what we found to be kind of the interface with the most activity, which is an interest is the E2 interface. So this is the interface that allows you to make what's called RIC applications for those who aren't in a space. This is a place where, as an outsider, it looks like the place where you could have the most potential for vendor interoperability, different vendors writing these applications that sit in the RAN. So let's talk a little about the E2 interface. I guess there's two things to think about when we're talking about the E2 interface. You have the E2 AP, which is one designation. So there's a protocol in there. It's called the SETP protocol that runs. It's for the transport for the E2 AP. And then you have this E2 SM, which is the service model that rides on top of the E2 protocol. It allows us for these what's called these RIC applications, or XApps. It allows them to broadcast these application-specific controls and events for them. So when you're coming from the cloud native community, you look at some of this stuff, it looks like service discovery, it looks like orchestration, it looks like that. That's what it looks like to me. But within these frameworks for the RIC, one of the things is it's called a near real-time framework. You need to, the applications here need to respond within 10 milliseconds to 1 second. And so that makes it to where there's definitely some more requirements that may not be serviceable in a regular orchestrator. I'm not so sure about that, but maybe so, and that's why you need this special type of management framework for making applications and so on and so forth. So you write these applications, and what they do is basically they're like RAN optimization applications that look at other parts of the RAN and manage them. So they look downstream at what's called the DU and the CU, and they can manage those things. But with this, these standards, it's an opportunity for different vendors to get in and write something that could be an AI app. It could be, all these other things that could manage the RAN, and you don't have to have these siloed, situations where everybody, has to, you have to go with one vendor. So very interesting. So now, how did we, or what tools did we use to test? We used SRSUE, we used SRSRAN, and SRSRAN has this cool thing, uses 0MQ to generate this traffic from the UE to the RU. The UE being the user equipment, like at the phone or what have you, to the RU, RU, the radio unit. And so that allows us to get away from having to have all this equipment, all this stuff. And then we use the FlexRIC framework for creating this XApp application, and of course the CNF Test Suite, or CNF Test Suite, to parse the captured traffic. We have labels. This is, we label the different pods in order to figure out what it is that we need to monitor. And we use T-Shark to capture the network traffic, but we use cluster tools, which is a tool that we wrote that allows you to get into the nitty-gritty in Kubernetes and integrate and monitor the traffic in Kubernetes. And the E2 app filter inside of T-Shark is another thing we use. So how do you run this thing? We have an example out there. You can just install and run. You got to install 5G cores, that command, a RAN simulator, which is the SRSRAN with a RIC. We have all that inside these two commands. And then you run the RAN E2 verifier, which is inside the test suite, verifying E2. Again, back to the different components of E2 that I said that you need to verify, and then you can inspect the outputs of the results. I'm just gonna, we've got this here. Run a quick demo. And we can get into some questions. So while this is running, I'm installing Open 5G, which is the core. And you're going to see it pop up on the right-hand side, all of the pods. I've sped this up so that we can have something that you can see. And then after this, after it's all started up, you go ahead and install SRSRAN, which is the emulator, and then the RIC inside of there. On the bottom right-hand side, you can see this SRSRAN. You can see the FlexRIC up there. And then I'm going to run what's called the E2, what we're calling the E2 verifier. It runs through, and it goes ahead and sees the E2 traffic. And so we're good there. Did that. And then, so we have our roadmap, and maybe Andre can talk a little bit more about this, but these are the different interfaces in ORAN. So we want to, depending on the feedback we get on what would be more high priority, the E1 interface, E2, we have that, but we need to do some more work there. These F1 interface for control plane, user plane, the front haul, the FAPI, NG, O1, and A1. And if you want to collaborate with us, we have all of our information right there. And we also, I'm going to go back to it, but we have another talk here in a couple, like an hour or so, talking about the CNTI Test Suite and what it tests. But here's our collaboration. Want to take a picture? Andre.
No, I think with that we leave.
Any questions?
Floor to questions now. Yes, please.
I'm gonna go.
Thanks for the presentation. How frequently do you run the CI/CD testing? What are the test results, test fail rates, statistics?
Yes, I mean for the in-house testing, so we go through various stages of the CI/CD execution depending on the granularity, and then so we actually run quite a bunch of tests on a PR basis. So those are executed for each pull request. And then once a feature or a bug has been developed, and this gets, in our case, into the development branch and past this pipeline, then we have nightly executions that will carry out a much longer test battery, involving more architectures, involving more compiler versions, involving more end-to-end tests using real hardware. That's something that we don't do on a pull request basis. And once that's completed and has passed the pipeline, that goes into a branch called next, which is essentially the next release, so to speak. And then there's even longer running tests that we execute weekly because they involve tests that actually take longer than 24 hours. So you can't do them in the nightly, otherwise you would accumulate them. So testing the RAN with test equipment. So we use third-party test equipment like Viavi TM500, and then have a battery of campaigns and tests to test mobility, UE attach for many users, and all of that. That usually runs on a weekly basis, and this is what becomes this is basically what becomes then the next release, and we do as a project, we do 6 monthly, so two releases per year that we tech, and that we go through manual testing and of course everything that's not in the pipeline, again, to make sure this is kind of like this release, but the main code that is promoted to and is public in GitHub, so we do regular pushes and all of that is regularly available. So
I think you already covered my next question. You don't really do CD then? I mean, it's not as soon as the functionality is deployed.
Oh no, yeah, we do.
Every 6 months is not.
The CD part is so we have actually internally we have a Kubernetes-based test and integration framework, and then all those tests are actually deployed as pods on on clusters. So this delivery and this testing is actually part of that. Is run in the in the pipeline, and the RAN is deployed on those nodes, and the tests are executed end to end. So this was not covered in this slide. I mean, we can talk hours about this, but this is as far as the in-house testing goes. And then the extension of that would actually be taking that outside and doing what I described, going in a redeployment and going outdoors. That's something obviously we don't do.
One more minute. Anyone? Question?
Thanks for the great presentation. I was wondering, you had a roadmap slide earlier. Was that based on the, I guess, what you've already implemented in the software, or is it based just on what you think is most important to test?
This is a roadmap slide for the test roadmap, so that Watson basically wants to include in the test suite. So we have most of those interfaces in the software, and then we do our internal testing with that. If you're referring to a roadmap slide for the RAN, that's something.
No, I just wondered, did you already have, for example, like an ORAN interface implemented, and you just haven't?
Exactly. Yeah. That's okay. I mean, we're like picking the low-hanging fruit, going through E2. It has been now. So like NG would be the next one probably. Then we can F1. That's a possible way forward.
Thanks. If you have more questions, just talk to us after.
Offline.
Yeah.
Thanks, everyone.